welcome back to Structures, but today we continue to analyze and design steel beam IPE 240 length 6 meter. We compare the result each other between the Soviet Advance Design with the Dlubal Rfem and also with the CSI Etabs. We designed based on the 0.3. Okay, the final result I will compare with my menu design in Excel sheet. We start from the modeling. We model the support as fixed support and apply the linear distributed load. This load 5 kN per meter length and line load also 5 kN per meter length. And the section of beam IPE 240, strength of the steel beam is 235 megapascal. This section is constant section from the start node to the node. We use the same material, and the method for analysis and design, analysis based on each software and design, we will compare each other. Now let's start from the software CSI Etabs. We will compare why the result of CSI Etabs different from other software and compare with menu. Now here this is the support, the assign fixed support and the element. Now let me show you the element. It's the frame. Okay, click on 3D. Yes, the I-beam section. Now let me click on one beam. Okay, enter, and the assign is IPA 240 megapascal. Define strength frame and IPE 240 megapascal. Modify property and the strength of this beam is 245. Okay, now let's start. Apply load. We have to turn off the extrude frame. Okay, now let me show the apply load. The load 5 kN. Okay, 5 kN per meter length. Yes, and the line load we also apply the same. So this model we apply for other software the same, for the Dlubal Rfem and for the Graitec Advance Design. Now let's start from the CSI Etabs. After we complete modeling, assign support, run analysis. Now I show the result of analysis. Click on the moment. Click on the load combination ultimate. Click on apply. This is the ultimate moment, bending moment on the beam. At the support is minus 44 kilonewton meter, and at the middle span is 22 kilonewton meter. Now let's show the design capacity. Let's review. We based on the 0.3, the national United Kingdom, and the load combination equation 6.10. etc. Click OK. Click OK. And click on design, steel design. This beam we do not apply lateral pressing or other pressing. This is the unpressed beam, so we have only support and support. Now let's click on steel beam, click on start design and check. Okay, you see the result with alert. Now let's continue to display the design ratio. Click on max ratio color PM. Okay, the maximum ratio is 1.26 1.26. Okay, we will compare later. Now let's jump into the Dlubal Rfem. Okay, this is the model in Dlubal Rfem. We model it's already also apply load. I will review the load. Okay, now let me review the load. Click on the yes, this one. Now let me change to the deload. Okay, the magnitude of deload is 5 kiloton meter per meter, and for the line load, where is the line load? Save as deload. Now let me check to make sure we have the same load case and load combination on all the software. Okay, now let me add new the save as deload and add new. This load case is the line load, and we change the load pattern to the impulse load. Okay, now let me change to impulse load. Click apply. Okay, and come back. We come back to the deload. Save as. Okay, now let me delete this load case, and now let's show the deload. Okay, and line load. Now let's apply the line load. 5 kilonewton per meter length. Okay, 5. Select. Okay. Click OK. Yes. After complete apply load, now let's come back to load combination. This software will be automatically update. Yes. Okay. Now let's click OK. This is the total load combination, and after that click on calculate all. Effective length. Okay, now let me input the effective length, the member standard member. Okay, now let me click on define effective length. Yes, 6 meter is correct. Click OK. Now let's calculate this again. Okay, now let's check about design and the ratio is 1.1. Okay, it's 1.1. Okay, now let me untick for load and check for the capacity only. Okay, 1.1, and you can check in the calculation note to check about the result. Yes, the result is 1.1 over 1. And we continue to Advanced Design 2023. And now let me run analysis and design steel structure. Okay, let's show the moment diagram. Click on force and maximum force load combination, and click on the Y. This is the ultimate load combination. 1.35 dead load plus 1.5 light load, and the maximum bending stress is around 44 kilonewton meter. And for the shear moment, and for the shear force is also 44. Now let's compare with the Etabs result. Is the same or not? Okay, come back, check with the MT3. Okay, it's the same. 2244. Yes. That's 2244. Now let's check with the Dlubal. It's the same or not? Click on the analysis, static, internal force, and click on the Y. Yeah, the load combination is 44 and 22. It's the same. So the internal force is the same. What is the difference between the result? When you show the design result in Etabs, the result is, now let me check again, display result. The result is 1.26, and the design result in Dlubal Rfem is 1.1. This here is 1.1 over the capacity of the section. Now let me show the result in Graitec Advance Design. Click on the stability, because stability control the design. We will check also. Yeah, you see here at the support is 95%. And now let me check in the strength. This is the cross section, capacity of the cross section. Let me check for the maximum working ratio is 51. What is different between the three software? I think this one is very big different for Etabs. Yes. Now let's compare with my menu. Let me check. I tie this section to IPA 240, and this is the partial safety factor and the property of the section. Yes, IA, IZ, IT, and the mass, the mass per length. Okay, now let me input the value. Let me input first compare with the Dlubal Rfem. Okay, the result we do the same in now let me show for the Etabs. So the result. Okay, click apply. Apply the maximum moment is 44. Okay, now let me apply 44 MED, and VED is the same, is 44. Yes, you can check and show for the VED, the shear force. Okay, yes, it's the same. And the condition we apply the destabilizing load. So it means that the beam, if when apply the load on the top plane of the beam also replacement lateral. Yeah, lateral, no restraint to prevent lateral buckling or lateral torsional buckling of this beam. So it's free to rotate, free to move to side. Yeah, to sideways. And now click on stabilize and load apply. We can apply at the shear center, at the bottom, and at the top. The case we apply at the top, we apply on the top flank. And the earn restraint condition is the fixed with distributed load. Okay, fixed with distributed load. Now let me change this one to fixed. Yes, distributed load. Now let's check the result. The result is 0.95. okay, 95%. The design control the lateral torsional buckling verify approach. This beam must be take into account the LTD, the lateral torsional buckling, because the value you can check W or CLT bar is greater than CLT 0 bar. So you must to take account the LTB check and verification. Now let me check for the yes, the strength we apply correctly, and the length and press length is 6,000 is correct. And finally the MCR, the elastic critical moment is 61.8. and for the BO, this value is either apply internal the internal moment result from the apply load. We input here is 44 kilonewton-meter. Now let's compare with the tape. What is different when you check? The first, we have to show the result or the design result. Okay, click on beam, right click, and the PM ratio is 1.26, and the station is 6 meter. Okay, the 6 meter is the location, and click on detail. Now let me check detail on the report. Each parameter we will focus on the parameter in Etabs, the label and unique and location. Yeah, combination, the section is correct, and the combination equation 6.10 zero code, the national United Kingdom is correct, and analysis type method 1. This is the partial certificate for steel 1 bond, and AV for the shear for the plastic. And now let me check. Yes, the strength or rebar of the beam is 235 megapascal is correct. The ratio, okay, this is the moment YED is minus 44 kilonewton-meter. Yes. Now let's check the MCR. Where is the value the MCR? We do not focus about the axial force because we use the beam to design receive mainly for the flexural and lateral torsional buckling. We do not check for the axial force. Now let me jump. We check with the parameter, the curve and alpha, and with the phi and C and NB or D. Yes, this is the MCO. Yes, the elastic critical moment. The LB is the LTD, the curve type is curve A, and the MCCO is equal to 32.29. Why it is different? Now let's check with my design menu. This is the MCO is 61.8. You see here, when you compare with the result in the Etabs, is only 42.3. Now I round up 42.3. Now let's compare each other. How much it's difference? It's over 68%. Why the difference so much? Now let me change this support, or let me check the parameter or the C1. Now let's check. In the case C1 is 2.57, and what is the result in the Etabs? C1 is only 1.132. So this one is very impact on the MCO. The MCO is the critical elastic critical moment. Elastic critical moment is equal to C1 multiplied with the other term. So this is very important when the C1 is not correct. So the result of MCO is also vary from the C1. Now let's check for other parameter alpha LTD. Okay, now let me check alpha LTD. Alpha LTD, yes, the correct is 0.21. Yes, 0.21. And lambda LT is 0.54. Yes, so it is different. Yes, this one, sorry, lambda LT, yes, 0.4, and phi LT is 1.64. Phi LT, now let me check phi LT, yes, 613. So it's different. Okay, let me check with the other parameter, is correct or not. Now I try to compare between the software and menu, between the software and software. This is the cross section. Yes, cross section A. To make sure my set is correct, you have to check everything here. Yes, EVU is the same, and EVIS, yes, it's similar, and WELY, WPL. Now let me check with WPL. Yes, 366 is similar. Okay, IT 13. This is WOIT. Yes, it's not the same, but it is similar. NEW. Yes, this view is similar. Yes, it's similar because I not guarantee W we input it manually when and the software is the same, but we can compare it. It's very similar. And now let's change and check it. When you check in the menu, what is different? Yes, the C1 in the Etabs is 1.13. Now let you check the C1. Come back. The C1 is 1.132 for the simple supported beam with distributed load, and the earn support condition is pin support, not fit support. You see here, the value of C1 in the tab is not correct. It's not incorrect. So we had to check and verify. A tab compute this value not much with the moment. This value very important. It depends on the moment shape. Okay, we can't depend on the moment shape. You can check the moment shape is yes, it's not implies supported beam. Okay, the earn condition of the joint, yes, the support condition is fixed. The Etabs apply the C1 for the pin support with distributed load. So this value is not correct. Now let me come back and check it again about the parameter, why the Etabs do not assign it correctly and why it compute is different from the menu. This is how we can check the software. Now I try to verify with the Etabs and check what is the difference. Now come back and zoom. Okay, let me check. this parameter C1, C2, C3 is depend on the earn condition or the support which open and the load. Okay, they apply the distributed load or point load, and the moment shape or the moment diagram also important effect on the C1, C2 and C3. And now the term ZG, the ZG, it is stand from the shear center to the portion or apply load. Portion or apply load is top plane, so it's equal to 240 divided by 2 is equal to 120 millimeter, and ZS is equal to 0 because the shear center and center of gravity is the same, so no distance. And ZC for the hot roll section, the signal or the planes and the shape of the section is symmetry, so ZC is equal to 0 is correct. So the Etabs consider the load applied on the top plane, not on the shear center. Okay, now let me check with my Excel set is correct or not. The load is destabilized. Okay, load applied at the top plane is correct, and you see the result is over. Okay, it's over. The section is cannot resist the applied load. In the Etabs is 1.26. Now let me change my Excel set. I change it to the strength pin distributed load. Okay, you see here I change this condition, and let me change it to pin distributed load the same. Okay, now let's check the result. This is the result is 1.27. Yes, 1.27. If you compare with the Etabs is 1.26. This is the final result, and design control is the LTD, lateral torsional buckling verification based on general approach. The close 6.322. And in my set I use two methods for LTD, use a general approach and use a method for IAH shape profile or equivalent well section. When you design for the equivalent well section or IAH section, the result is lower than your general approach. For the section I and H, you can use the specific approach. You can use this approach for calculate. And for the general section, the section hot rule section and the constant the beam is a constant section, not variable. You can also apply with the general approach. Okay, now you see here the result of general approach is higher than the equivalent well dissection. Okay, now let me come back and check the result compared with Etabs. You see here the C1 is 1.132. When you compare with the Etabs, again click detail and click on envelope control to check the result. Now let me check the result. Okay, you see the result of C1 is 1.132. Yeah, and MCO is equal to 32.26. Now let me check. The MCO now is 32.1. This is my sheet design. Okay, my sheet design 32.1, and in the Etabs is 32.29. So Etabs, when you change the support condition, the parameter inside the beam is not changed. This is a big issue, a serious issue when you design the zero code based on the Etabs software or CSI product. You have to check it again and again, and it's very concerned when you design the software. You have to make sure you can verify it and know why it's different. You see here the parameter C1 is for the simply supported with distributed load, and ZC is 120 is correct. Yes, ZC 120. You see here there are a lot of formula here to calculate when you use Excel set. It's not the same. It's not easy as a market frame. You can compute it easily, find it, and the unit automatically convert. But Excel you have to convert the unit. You have to make sure the sheet you make it correct, to verify it again and again. Now WEC1 and WEC2 is 0.456 0.459. Now let me check with a tape. Yes, C2 is 0.459 is correct. So this parameter also C3 is 0.525. Now let me check. Okay, 0.525. This parameter for the simply supported beam, the unrestrained is a pin connection with distributed load. Yes, pin, but actually we apply in the tape is with distributed load. The tape compute the parameter from the C1, C2, C3 is for the pin support with distributed load. You see here why the result of the tape is not much with the Excel sheet with manual calculation. Yes, now let me check the result of 0.5. This is the result for the